Hello there. So today we're going to look at topic 1.9, least common multiples. And for this lesson, we're going to focus on a few different methods for finding the least common multiple. And this will become very useful for us when we're adding and subtracting unlike fractions. So multiples are the product or answer of numbers that are being multiplied. So for example, if you look at the multiples of 6, what that means is we're counting up by sixes. So we're using multiplication as a fast method. So if we're looking for our multiples of 6, 6 times 1 would be 6, 6 times 2 would be 12, 6 times 3 would be 18, 6 times 4 is 24, and so on. So we can just keep going and going and going. So multiples of a number is the number being multiplied by other factors, 1, 2, 3, and so on. Now, least common multiple is where you're trying to find the number that two or more numbers can hit, basically. So what we're doing here for method 1 is we're looking for common multiples of 6 and 8. And actually, there's not just 2 methods, there's 3 methods we're going to look at today. So let me change that there. So we're going to be finding common multiples of 6 and 8, and method 1 is that listing method that I showed in the example above. So it's a very good method. So what we're going to do is start with 6 and start to write the multiples of 6 like I did in the earlier example. So I'm just going to go 6, 12, 18, 24, 30, maybe 36. So you don't really know when to stop. This is the one thing about this method that I guess could be problematic, but you can definitely write a few and then see if you find a common multiple. So with the 8, we're going to go up by 8s. So 16, 24, 32, and there we can see that we have a multiple that is the same, and it's 24. And we're looking for the lowest number we can find that they both create, right, through the multiplication process. So the lowest common multiple of 6 and 8 is 24. Okay, so this method works really well if you've got little numbers like 6 and 8. You can even just do this mentally. But when the numbers get quite large, this method maybe isn't your best option, but it's definitely a great method for a lot of numbers. The second method is using prime factorization. So we're building our factor trees, and this method works particularly well if numbers are quite large. The first example has 2 numbers that aren't that big, but it's a good starting point for us. So lowest common multiple of 9 and 12. So if you remember our factor trees, we're going to start dividing by prime numbers. 9 is divisible by 3, and so 9 is the result of 3 times 3, or 3 squared. 12, we can divide that by 2, giving us 6. Divide by 2 again, which leaves us with 3, and there are our prime numbers 2, 2, and 3. So I write this with exponents, 2 squared times 3. So then what we do for this method is we say, okay, let me take 2 numbers that are different and the highest of those 2. And that's why using exponents is really helpful for us, because we see that we have, for the 9 it's 3 squared, and for the 12 it's 2 squared times 3. So what this means is I'm going to take the 3 squared, and I'm not going to take the 3 coming from the result of prime factorization of the 12. Because it's the same number, I'm not taking it. I'm going to take the 2 squared as well. So what I'm saying then is the lowest common multiple is the result of 3 squared times 2 squared. 3 squared is 9, 2 squared is 4, and so the lowest common multiple of 9 and 12 is 36. So this method is a little bit longer. With small numbers like 9 and 12, you may be better off using method 1, going up by 9s, going up by 12s, and getting to 36 that way. So that was method 1. But the prime factorization method works well, particularly when the numbers get bigger. And that's the example we're going to look at now. So we're going to do a factor tree for each of these numbers. We're going to write the prime factors and we're going to use exponents. This is how this method works. And then we're going to take the largest multiples from each list and we're going to write their product. So we're only taking one from each list. So I'm going to show you how to do the lowest common multiple of 120 and 45. My method's slightly different than the textbook, but the result will be the same. So the way that I'm different is the 120. I'm going to make my factor tree look a bit different than the book shows because I am going to use my smallest prime number, which is 2. So I'm going to go ahead and divide 120 by 2, which gives me 60. I'm going to keep dividing by 2 for as long as I possibly can. So 60 divided by 2 is 30. 30 divided by 2 is 15. Now I can no longer divide by 2, but I can divide by 3. And that's going to leave me with 5. So my method is starting with those little guys. I talked to you about that in the previous lesson. That's my preferred way. The textbook shows a different method, still getting the same answer, but what I like about this method is all my numbers are in a nice order. So the result of 120 is 2 cubed times 3 times 5. Okay, so this is where prime factorization really shines. For 45, I can't divide by 2, but I can divide by 3. So I'm going to do that. So again, my method is a bit different than the book. Same result though. 15 divided by 3 is 5. And so I'm going to be circling my prime numbers. That will give me 3 squared times 5. So at this point, we say, okay, I've written my prime factors with exponents. Now it's the decision time. And this is where it can get a little bit tricky if we're not really sure what to do. What we're going to do is we're going to take the largest multiples from each list. So on the 120 side, I have a 2 cubed. On the 45 side, I don't have a 2, so I have to take this one. Okay, if I don't have ones that are matching, I have to take the one that's just kind of by itself. So the 120 gives me a 2 cubed. I take that one. Now check out the 3's. 120, I just have a 3. On the 45, I have a 3 squared. 3 squared is bigger than 3, so I'm going to take this one. So if they match, I take the bigger one. If there's nothing to match, I have to take it. For the 5's, I have a 5 and a 5. They're the same, so I can take either one of them, but I can only take one. Okay, so I can take one of them only, so I'm just going to take this one, but I could have taken the 5 over here. So the ones I've circled are together going to be the lowest common multiple. The lowest common multiple is going to be 2 cubed times 3 squared times 5. So now we're going to actually solve this. 2 cubed is 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8. 3 squared is 3 times 3, which is 9. And then we're going to multiply by 5. So we're going to take 8 times 9 times 5. And when we do that, we're going to get 360. So the lowest common multiple of 120 and 45 is 360. It's a lot of work here, but it's pretty cool, and the prime factorization works very, very well with large numbers. So that's method 2. We do have an alternative method, and I've got to say the alternative method is probably my favorite. It works really well, especially if you're trying to find the lowest common multiple of 3 or more numbers, because sometimes you have to do this. So I've got an example here where we're looking at 12, 21, and 24. And so what I'm going to do here is I'm going to write them beside each other. And I'm going to make a funny little kind of box. So I'm going to make a line here and a line like that. Okay. And so what we're going to do is follow the same kind of rules as prime factorization. We're going to be looking at our smallest prime numbers, 2, 3, and 5. And we're going to be starting with a 2 whenever possible. So what I'd like to do now is I'd like to try to divide them by 2. It doesn't matter if they're not all divisible by 2. So I'm going to start right here. So I'm going to put the first 2 there, and I'm going to start to divide. Okay. So what I'm going to do is make a second row so that I can put the answer underneath. 12 divided by 2 is 6. 21 is not divisible by 2, so I just copy it down. 24 is divisible by 2, so I divide it by 2, and the answer is 12. So my first row is done, and I just continue doing this. I go ahead to my second row. I make a space to put my answers, and I start to divide by 2 again. 6 divided by 2 is 3. 21 is not divisible by 2, so I just write it down. 12 divided by 2 is 6. And I keep going. I must keep going with 2's until I can't use it anymore. So 3 does not divide by 2. So I just write it down below. 21 does not divide by 2, but 6 does divide by 2. 6 divided by 2 is 3. So now I've exhausted my 2's. I'm going to go ahead to divide by 3 now. So I go to my next prime number. Can I divide these by 3? Yes, I can. So I write that down, 3. I make a space for my answers, and I divide. 3 divided by 3 is 1. 21 divided by 3 is 7. 3 divided by 3 is 1. So I'm at this row where I have 1, 7, and 1. I can't divide anything by 5, but my next prime number and my last one I'm going to use is a 7 here. So 1 does not divide by 7, so I just write it down. 7 divided by 7 is 1. 1 divided by 7 I can't do, so I just write it down. And I have reached my goal, and my goal is where I have all my answers getting down to 1. 1, 1, 1. This means I'm done. So what is my lowest common multiple? My lowest common multiple is the result of all the numbers that I used for prime factorization, all the numbers I divided by. That's going to be 2 times 2 times 2, right? 2 cubed times 3 times 7. Let's figure this out. 2 times 2 times 2 is 8. 8 times 3 is 24. 24 times 7 is 168. So the lowest number that 12, 21, and 24 make